So second, what is the first second objective? Understand pure in bracket single compounds, fluids, dynamic property, thermodynamic properties and their correlation laws. What is the meaning of that? What is the meaning? Mean single compound. Single means that is called pure. Okay, so pure compounds thermodynamic properties. Initially we will just discuss in the first objective on what are the different thermodynamic properties. Now what is the, for example, oxygen is there, or hydrogen is there, or water is there. In a water no other compound, only water is there. Because we are saying fluid means, what is the fluid means? Both will come. So means only single compound thermodynamic properties. Okay, how? That we will discuss in the second unit. Okay, only single compound thermodynamic property. What are the thermodynamic properties? What is the volume? For example, the temperature is changes, how the volume is changing. For example, pressure is changing, how the temperature is changing. So we will discuss the properties. Okay, not only the properties, property relations, correlations. Property correlations means correlations means, for example, one property in a system, water is there, in a beaker water is there. Okay, so water is the temperature, the water temperature initially room temperature 25 degrees centigrade. After that the temperature, the beaker is started heating up. Okay, so while the temperature is changing, how the other properties like how the density is changing, how the viscosity is changing, how the volume is changing, how the pressure is changing, how another properties means other like what the concentration is changing, is there any relationship, means, so like these correlations. So if mean what we can know from them, we can easily, from using this correlation, we can easily determine the unknown properties. Okay, we no need to do again for the experiment. For example, if I want to know the density of at 30 degree temperature of water, I have to do experiment. Okay, no need to do that. So thermodynamics deals about the how to develop these correlations within the pure fluid properties. So that we'll discuss. So that if I know one thing, if I want to know another property, using this correlation without doing any experiment, I can easily determine the other property. Okay, so that is the second unit deals about that. Okay, next third unit, same thing, just mixture. Okay, and to understand mixture, solution properties and their correlation laws. To understand the mixture, solution properties, you are not writing? Started writing? Please write. To understand the mixture, solution properties and their correlation laws. Okay. So in the second unit, only pure single compound, now mixtures. The two compounds are there. In the two compounds, if I am applying the temperature, because of that some property is changing. If the one property is changing in the same mixture, another compound property is changing. Okay, how to determine them? So and correlations. Okay, in the second unit we'll discuss the only single compound of the property correlations. Third unit, mixture compound property correlations. Okay, laws. So that is about the third unit. Fourth one, to understand thermodynamic phase equilibria. To understand thermodynamic phase equilibria between vapor dash liquid vapor hyphen liquid, comma, liquid, comma. First one is the vapor liquid, comma, liquid, comma, vapor solid, comma, and vapor solid. So 4 came now. Liquid solid next one. Vapor liquid, vapor solid and liquid solid. So in the fourth unit, so how to determine the phase equilibrium? For example, same example, in a beaker, small beaker, you have a small beaker, water is there. So that is you are completely closed, sealed it. So you are from the bottom you are heating up. So when the water temperature reaches to the boiling temperature, 100-degree temperature, so what will happen? Yeah, the water converted into phase change. Okay. After some time, how much temperature you go, it cannot be done. Means the water cannot be converted into the liquid vapor phase. Do you know why? Because the water and vapor both are reached into equilibrium. Equilibrium means, what is the meaning of equilibrium? What is it? Do you know any equilibrium meaning? Equilibrium? Equal. Very good. Equal. Means, so initially, the beaker, when the beaker is there, in that water is there, you are started heating up. The water, the molecules are converted into vapor phase. So means initially very few molecules are entering into the vapor phase. Okay, entering. After some time, so vapor also again come back into the liquid phase also. So means this transformation continuously will happen. Means some water molecules are converted into the gas molecules. Gas molecules are converted into the liquid phase. But after some time, the 10 molecules are coming from the vapor to liquid, for example. Same 10 molecules of water water molecules will enter from the water to liquid phase in a same ratio. Okay, means if for example, how many are here? 1, 2, 14. I said, can you 5 members please leave the classroom? But 5 members are waiting there and they are entered. What is the total class time? 14. Every second 14 only, because 5 members are leaving, 5 members are coming. Means this is called equilibrium. It is not like uniform. Means you are not sitting stand like it means stable, no movement, not like that. Okay, that is not a uniform. Uniform is everywhere is the same as a uniform. Constant is you are not moving anywhere. Like for example, what is the constant number of second year class? For example, 14 today. 14. But equilibrium means there is a movement in the molecules, but this move equilibrium means it is also stable. We can call also stable, but number of molecules are leaving and number of molecules are entering is the same, always same. So that the total class always remaining same. So that is called equilibrium. Means we are going to discuss in this example. You are started heating up the water, which is there. The water is there in the beaker. So that is a closed beaker. You are starting heated up. So water is converted into vapor phase. After some time, how much temperature you give, the water cannot convert into the vapor. That is completed stop. So means that is reached equilibrium. If that is the case, if I want to more steam, I cannot generate. Because the steam and water both are reached into equilibrium. So means the thermodynamics deals about the when they are going to reach the equilibrium, how to disturb the equilibrium so that I can get the wanted vapors, more vapors. Okay. So that is the thing. Okay. So this is for example vapor, liquid vapor, and solid vapor, and solid liquid, and liquid. So liquid also will both reach equilibrium. Do you know any example liquid equilibrium? Mixtures. Okay, liquid phases. Oil and water both are a liquid both are in a equilibrium state. You were saying something? Emulsions. Emulsions are the equilibrium. Emulsion solid, yes. Means we cannot call that the equilibrium state. We can say two phases are in a one compound. So of course there are, because of they reach into equilibrium only, they are in a stable condition. That is true. Yes, correct. Okay. So that is the fourth unit. What are we going to discuss in the fourth unit? Phase equilibrium. How they are going to reach the phase equilibrium? How can I disturb the equilibrium? How can I reach the equilibrium? Otherwise, how can I get the equilibrium? These are the things we are going to study in the fourth unit. Fifth unit. So study to understand the thermodynamic chemical reaction equilibria. To understand the thermodynamic chemical reaction equilibria. To understand the thermodynamic chemical reaction equilibria of homogeneous and heterogeneous reactions. Okay, homogeneous and heterogeneous reactions means now same equilibrium, but in between the chemical reactions. Initially there is no reaction in the phase change. Is there any change in the phase change? Is there any chemical reaction in the phase change? No, just the matter is changing from one state to another state, but there is no chemical change. Chemical change means what? What is the meaning of chemical change? How the new compound going to be formed? Chemical reaction. I am asking again. What is the chemical reaction? Yes, Bharadwaj, you are saying something. Reaction. What is the reaction means? What is the chemical reaction? What? Okay. What is the difference between the physical reaction and chemical reaction? Bond formation. But in a physical reaction, there is no bond formation. Molecular properties change due to the change in electrons. Okay. So means, for example, water molecule is there. The water molecule, always the water molecule in the physical change. There is a bond in the physical also. Van der Waals forces are there. Hydrogen bonds are there. And OH bonds are there. There is a bond. So that's not like that. So water is staying in a liquid form because of the hydrogen bonds. There is the bond, and van der Waals forces are also there. But in a chemical change, electrons are, for example, in a water molecule, number of electrons are this many. So the number of electrons are going to change. So because of the number of electrons are changing, the compound is different. Everything will be changed. So means chemical change means changing the number of electrons or protons. So because of that is the only. But a physical change, there is no change in the electrons or protons, only change in the bond. The bond, one bond is going to, for example, both are these two are sitting together. So with the physical change, I ask you to move to next one. She will come to here. So just only physical change means bond replacement only, unless that there is no change. But like what is your name? Harshini is always Harshini only. There is no change in the Harshini. Just place transformation only. Okay, but chemical change is different. Means completely Harshini is going to be like a Chinmay, something like that. Because of the change in a molecular structure, atomic number. Okay, so that is a chemical. So now we are going to discuss how the chemical reaction is going to take place. For example, A plus B going to be C. Okay, so A plus B going to be C. So this C is a compound. So when this C production, C is our desired product. When this production is going to be stopped? Huh?
It will start dissociating back to A and B.
Means reversing back. When, yes, that is true. But when will be happen? So means this is called equilibrium. Means A and B compound concentration very initially they are rich in concentration, so that they will add together become a convert into C. After some time, the C concentration and AB concentration both are coming same. After some time, so that there is no driving force to go. So for example, in the universe, something is moving or something is happening, there is a driving force. So driving force is not there. Okay. So A and B are going to be C because of there is a driving force. That is the driving force is the concentration. Okay. For example, water you are heating up, the water molecule convert into the into gas phase. There is a driving force. What is the driving force? Heat is a
Free energy, sir.
Free energy. Free energy. Because of the free energy, there is a work change. No, because the pressure difference. Because of the pressure difference, the pressure both are same. Then there is no change in it. Okay, so like that. So for every change in the universe, because of the driving force, it could be the temperature driving force, it could be the concentration driving force, or it could be the other driving force. Whatever the change, because of the some driving force. In this chemical reaction, A plus B going to be C. In this chemical reaction, there is no driving change after when they are reached into the equilibrium state. So now we are going to discuss in that unit when there are going to be a equilibrium, how to overcome this equilibrium, how to avoid the equilibrium. Now, for example, I will tell one example. Before thermodynamics was not there, one reaction is there, that is the ammonia NH3 is going to convert into the ammonium hydroxide is going to convert to the ammonia. The reaction is there. So this ammonia is Haber's process. Very good. Yes. So it is reacted with the sulfur. Sulfur only, na? So but so whatever the initially the conversion efficiency, efficiencies may be, for example, 50% we consider. They thought we want to increase the conversion amount. Okay. But what they thought, maybe contact time is very less, so that the conversion is not good. So that what they thought, they increase the furnace area. Big furnace they fabricated or they designed, and in that they put that, they did the reaction. But the same conversion, there is no much change, only 1 or 2. Then after the thermodynamics was born, after that it is explained not because of the contact time, not because of any other, because of they both are reached into equilibrium, so that there is no conversion. So then they try using this thermodynamic knowledge, they try to shifted the thermodynamic equilibrium, so that whatever the direction, if I want to move to that direction, means I want to ammonia, then they change the parameter which are helping to not forming a equilibrium, so that conversion is happening, means conversion amount is more. So that's means this thermodynamics will help you to study when one particular reaction is going to reach equilibrium, when how to avoid this, how to get our conversion, how to get the equilibrium. So these are the things. Okay, this is the 5 things. Just 1 or 2 minutes, please meditate on these 5 objectives. Please take time and meditate on these 5 objectives. So you both please come here, you are sitting alone. You are sitting alone? You are not getting isolated from the classroom. You are also friends to them also. Please come. You are also part of the classroom only. Please don't be isolated. There are the friends only. So next time you must Come, wherever. Other district changes in achievement. Okay, so meditate it, please. So these are the 5 objectives we are going to be studying. Okay. So after meditation, so now what are the course outcomes now based on the objectives? What are the course outcomes?
To utilize heat energy to improve work.
Course outcome means, for example, unit wise. For example, first unit. After studying the first unit, the student able to understand properties. Means you put your name, like a Chinmay, put your name. Chinmay, after reading after completion of the first unit, I am able to understand thermodynamic properties and laws of thermodynamics. Okay. So what is the second unit objective? And now course outcome. Second unit outcome. What is the outcome?
To understand
That is the objective. Now I am able to understand. Please read yourself. I am able to understand pure compound thermodynamic properties and correlations. After completion of the second unit, you must be able to outcome. That's your outcome. The outcome has to come. Then there is a problem in the something problem in the faculty or problem in the student. Okay, that outcome has to come. There is no doubt. After completion of the second unit, I am able to understand pure compound thermodynamic properties and correlations. If it is not happen that, there is a problem. Okay. So what is the third unit outcome? Now, good name, your good name? Shravya. Can you please read out what is the outcome of third unit?
I am able to understand mixture solution properties and their correlation laws.
Mixture solution properties and their correlation laws. Very good. Next, fourth unit. Equilibrium and between the that you are able to must understand after completion goal. The fifth unit she will do.
I am able to understand thermodynamic chemical reaction equilibrium of homogeneous and heterogeneous reactions.
Reactions. Okay. So these are the outcomes. Okay. Sorry. Now write unit 1. Put the heading unit 1. Unit 1. Unit 1. Content. Unit 1. Please write the unit 1 in that content. Content. First one is the types of energy. Types of energy. Types of energy. Work. Second one is the work. First one is the types of energy. Second one is the work. Third one is the heat and energy changes. Third one is the heat and energy changes. Fourth one, applications of first law. Applications of first law of thermodynamics. Applications of first law of thermodynamics to different processes. Different process. Okay, she will read. Can you please read out now whatever the things you have written? Content. First unit content.
Types of energy.
Types of energy.
Second one work.
Work.
Heat
Third one is
energy changes.
heat and energy changes.
Application of first law of thermodynamics to different processes.
Very good. So it is not yet completed. Next one is the fifth one, entropy. Next one is the reversible and irreversible process. Reversible and irreversible process. Next one, Carnot cycle, C-A-R-N-O-T, Carnot cycle. Next one, TS diagram, T hyphen S, T hyphen S. Okay, diagram. Next one, enthalpy of mixing, enthalpy of mixing and disorder. Enthalpy of mixing and disorder. Sixth one, last one, refrigeration and liquefaction. Refrigeration and liquefaction. Liquefaction, liquefaction. So this is the content of the first unit. Okay. So from the entropy, please read last. Read from the entropy onwards.
Entropy, reversible and irreversible process, Carnot cycle, TS diagram, enthalpy of mixing and disorder, and refrigeration and liquefaction.
Very good. So this is the content of the first unit. So means first you will see the some what is the types of energy, what is the work, what is the heat and what energy, how the heat and energy changes, and what are the application of first law of thermodynamics. And next, what is the entropy, what is the enthalpy, what is the Carnot cycle, what is the TS diagram. Next, what is the refrigeration, what is the liquefaction. Means how can I convert something into liquid, how can I convert into something into solid. Refrigeration, that is the only, refrigeration means something I convert into the more, not more, it is reduce the temperature. Reduce the temperature or increase the temperature. So when I reduce the temperature, they are converted into the solid state or temperature is reduced, that is a refrigeration. And some liquefaction is something is there, some gas is there that I want to convert into the, for example, oxygen is in a gas form. I want to convert into liquid form. How can I do that? How much pressure you want? How much pressure you want? We don't know. So that is called work. So that we have to determine first that much pressure we need to apply. We need to develop the machine such a way that will create that much pressure. Otherwise, randomly you develop something that is not producing that much pressure. So air is coming, the air is outlet also, inlet is air, oxygen, outlet also air only. So what do they use? Your efforts, your everything will be lost only. So mean first we need to calculate how much pressure it requires to convert the oxygen which is there in the gas form. I want to convert it into the liquid form. How much pressure is required? So then, and after the calculation of that, so then we can design that it will develop that much pressure. So we can convert it into the liquid. For example, do you see any way like oxygen is in a liquid form? You don't see? You will see many times. Hospitals, every hospitals, oxygen.
Scuba diving people will carry oxygen.
Oxygen cylinders, very good. Scuba divers. Okay. And hospitals like these tourist places. And who else carry liquid oxygen?
Fire extinguisher.
Fire extinguisher, excellent.
That is carbon.
No. Oxygen only. They will carry oxygen and they, because full of carbon dioxide, they cannot have the oxygen. That is correct only. Who else? Hill climb, very good, especially Himalayas. Himalayas, there is no much oxygen availability. Astronauts, excellent. Why don't you have a oxygen in the Himalayas? Why do people carry it?
Altitude is higher altitude, lower pressure, lower pressure.
Because of the low pressure, oxygen is not available. Of course, because of the altitude, pressure is low. That is true. Because of that, oxygen is not available.
Partial pressure of oxygen decreases, so we cannot intake.
Partial pressure of oxygen. Partial pressure means you know na? What's the meaning of partial? What's the meaning of partial pressure?
Pressure of a particular gas in a mixture of gases.
Okay. Means in that area, according to her opinion, I am not concluding that our opinion is correct. In that area, the partial pressure means the oxygen molecules creating the pressure is very, very low, so that they cannot move one phase to another. So otherwise, we cannot breathe them. Okay. So these are the, of course, reasons are correct mostly. So another question is, why do you want to convert the oxygen into liquid form, gas into liquid? Why? One by one, huh? To carry. Why don't you carry the gas form only?
Large amount of gas.
Very good. Yeah. She said correct only. Because if I want to carry more amount, it has to be converted into form. Then you can convert it to solid form. Nah? Why are you converting the up to liquid only? Why? According to Bharadwaj, it cannot be converted. Why? Question is why? Why it is not acceptable? So it is appreciable if you are able to convert the vapor oxygen into liquid form. From the liquid to gaseous form, you are the scientist.
Oxygen molecules are not based to form a solid form.
If you
Molecular oxygen cannot be formed into a solid state.
no, that's not correct. Pardon? Yes.
It's heavy to carry things.
Heavy to carry. Maybe that is a single disadvantage, but that is not correct. Actually, it requires lot of energy.
How will you please say?
Solid cannot to be.
You cannot.
The reason is,
Process, we have to come.
please listen. Reason is, it will take lot of cost. That's the only reason. It can be converted. See, yes, why not? So for example, iron is there. Iron is a metal state. It can be converted to liquid state. It can be converted to gas state also.
Yes.
It can be converted to the plasma state also.
Yes, sir.
So why not? Means everything is possible. But iron is a metal. Metal can be converted to gas state. So then why can't you convert the oxygen molecules which are in a vapor state into the liquid state, from the liquid state to solid state? It is possible, but energy consumption, cost effectiveness is very, very, very high. That's the only reason. I cannot carry diamonds to do small work. That's the thing. That's the only reason. Okay, but I need oxygen, so that conversion of gas state to the liquid state is sufficient. So the cost effectiveness is up to that sufficient. Okay. So only based on the cost effectiveness only. Yes. So that is the refrigeration. Liquefaction means, that is liquefaction I have seen. Refrigeration means
Reducing the temperature.
reducing the temperature. So reducing the temperature. Why do you want to reduce the temperature?
Solidify or preserve.
Preserve. Excellent. Solidify to where else you will see the refrigeration?
To get the freezing point.
To get the freezing point. Of course, that is the solidification. Both are same only. Very good. What else? Where do you need the refrigeration? Preserve, she said, means you are using in our homes refrigerator to preserve our food. Like milk, some dairy products. If you want to preserve it, so you need the refrigeration. Okay. Another question again. So if you want to preserve it, something like a food and dairy products, why do you want to reduce the temperature?
Microorganisms don't grow at that temperature.
Very good, excellent. So microorganisms cannot grow at that temperature. Okay, if that temperature is not sufficient, the temperature won't help you to grow more microorganisms. Microorganisms will grow even though you keep in the refrigerator for a long time also. It will. In long time they will spoil, there is no doubt in that, but the growth rate is very, very less. That's the only thing. Okay, so refrigeration means to preserve the food and to convert something into solidification and avoid in the industry, especially for example, I want to do some reaction. I need temperature is minus 40. How can I get the minus 40? By refrigeration. So means I have to maintain the certain temperature, we need to do refrigeration. So in that refrigeration, we need to take some liquid or some gas, bring them the temperature into minus 40 due to some equipments. So from there we can get the temperature, we can apply that temperature to the reaction, and the reaction will take place. Okay, so that is the thing. Okay, so this is the first unit content. First, so next one. First, yeah. Now I will textbooks. Please write the textbook names. Textbooks. Please write. Textbook names. So this tomorrow is actually class are going to stand, but the bench are still like that only. Okay. J dot J, first book name, J dot M dot Smith. J dot M dot Smith, SMITH, and H dot C dot J dot M dot Smith, and H dot C dot Van Ness, VAN, Van space NESS, Van Ness. Smith and Van Ness we call generally. Okay. So an apostrophe, please write. Introduction to Chemical Engineering Thermodynamics. Book title name. Introduction to Chemical Engineering Thermodynamics. Introduction to Chemical Engineering Thermodynamics. Okay, that is the book name and author's name. Second book, K dot V dot Narayanan, 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 K.V. Narayanan, in apostrophe, a textbook of Chemical Engineering Thermodynamics. A textbook of Chemical Engineering Thermodynamics. That is a title name. So these are the textbooks I refer and teach you from them. So you also can refer from them. Okay, you can see. Okay. So these are textbooks. Smith and Van Ness, that is the title is Introduction to Chemical Engineering Thermodynamics. Second one is the K.V. Narayanan.
Textbook of Chemical Engineering Thermodynamics.
Last year. So can you please bring the some charts? Anyone? While coming, can you please close the door? Okay, na? So are you getting bored continuously being as a class here? No, na? No, I think it is bored.
No, sir.
Huh?
No.
No, it has to be changed.
No, sir.
Every time there are only. There will be operation for the So maybe this time we will try to change. Because every time that is not correct. Every time one man is saying class here. This semester has to be at least one every year. Okay, I will talk to class in charge, Balchandra sir. I will talk to the class here. Because we will need opposite. Does not mean that you are not doing anything like that, or you are not doing anything like that also. But just for change purpose. Has to be due to others. So they will also do. Okay. Please, give me care. It's okay. Bad catch as bad throw. Which one is correct?
It's a bad.
Both are correct.
Bad throw.
Both are correct. Okay, so how can I go? I cannot go now.
Yeah.
Okay, so means for example. Yeah, now next one is the introduction to the. Please write introduction to next one. Introduction to CPT, Chemical and Process Thermodynamics. Textbooks are completed now. Next one, introduction to introduction to CPT.
Chemical and process thermodynamics.
Chemical and process thermodynamics. Okay. For example, so one reaction is there, that is A plus B is going to be C plus D. Okay? Yes, Chinmay, you can ask me doubt. I am there as a class teacher to clarify your doubt, not your friends. Okay? Please ask me. I am very happy to clarify your doubt, any silly doubt also. Okay? So please don't disturb your friends because they also don't know anything. So they are also like you only. Please ask me. So maybe I am little more better than your friends. Okay? Yes. For example, A plus B, any chemical reaction is going to be C plus D. Okay? So have you visited any industry?
Yes,
No?
sir.
Yes, sir.
Industry.
Also.
That's not an industry. It was an industry.
It was.
It was an
Okay, what is that industry?
pharmaceuticals industry, sir.
Pharmaceutical. What is the name of that industry name?
Pulse pump.
Pulse Pharma. So what is the
They make powders.
They make
Protein
different
powder.
they are
powders.
preparing the powders. What type of powders they are preparing? Any drug name? Do you know?
Protein powder.
Protein powder they are preparing. Okay, very good. Protein powder they are preparing.
Nutritional powders.
Huh?
Nutritional powders.
Protein both are same more or less. Okay, okay. Whatever it is. So what are the raw materials? Do you know raw material? Raw materials. Because they have a flow chart. Now, do you have
Yes,
a?
sir.
So do you have anyone has taken a picture of the flow chart or the process?
We wrote it in the report, sir.
Okay, noted in the report. What are the raw materials they are taking to get that protein or nutrient powder? What are the raw materials they have taken?
We take a lot, sir.
Please tell me one or two.
There was for the sugar content they used fructose, sir.
Fructose is the one raw material. Any other? What is the main ingredient?
Source of protein, sir.
What are they? Milk, meat, wheat. Wheat they have protein. Fiber they have. Yes, Bharadwaj.
Make powder.
They are not from the business side.
Means I am just asking what are they are using? What they are using to get the nutrient powder, nutritional powder. Yes, somebody. What are the raw material they are taking? You forgot. Few members. That few members are here. Bharadwaj and Chinmay. You. Only 3 members. Only these 3 members. Okay. So you forgot. What are the
Actually, they were making small components, sir.
true? But what are the raw materials?
For that component also they had some very complex raw materials, sir.
What is that complex raw material?
We don't know.
Okay, leave it about that. For example, okay, we'll come to the this. For example, because I want to explain the real example because you have already seen that reason I want to explain that. But okay, for example, A plus B, you take the maybe what is the protein rich content? Any food name? Protein rich content.
Meat, sir. Meat.
Fish.
Meat. Meat plus another one.
Which one, sir? Protein, sir.
Protein rich. No. Now vitamin rich, not nutritional rich content. Many are there.
Spinach.
Spinach. Okay. Spinach. So the mineral rich. Spinach is a mineral rich content, not a nutritional rich. Okay. Okay. For example, from the nutritional powder is preparing. For example. Okay. Okay. First, what they will do? First, what they will do? They will first A is coming here in a storehouse. It is there, and the B is there in the storehouse. Both are coming from here, and they will mix somewhere. So, for example, this is a mixer. Okay, means A is coming, for example, in the liquid form. B is coming also in a liquid form. For example, both are coming. Means how to transfer a one fluid from one place to another place. So that you studied in the fluid mechanics. Fluid mechanics means whatever the subjects you are going to study are useful in your pharmaceutical industry. Okay, so that means the two raw materials you need to send to mix. So how to transfer them? So that is fluid mechanics will explain how to transfer any particular fluid which is there in the solid phase, liquid phase, or gas phase. Solid phase also will discuss. Maybe that is the next level. Okay. So that is the fluid mechanics will lead how much pipe diameter should be. How much pressure it will sustain. For example, one material is there. That material is it can produce very pressure. Pressure means force per unit area. Surrounding the walls, pipe is there. Pipe walls are there. It will produce lot of pressure. Then, if you are maintaining the pipe thickness is some particular then pipe will burst. So, means what is the standard thickness that particular material? So what is how much pressure will create this fluid? So that will be calculated using the fluid mechanics. From there you will design what is the thickness, at least thickness required. Critical thickness means economical thickness. It is not, for example, you cannot take 100 mm now because it is not cost wise. The industry means everything is a cost based only, economic, profit based only. So we cannot design the 100 mm thickness pipe. So what is the critical? Means that thickness is sufficient to bear that pressure. So that we discuss in the fluid mechanics. Okay. After that, these A and B are into the mixing tank. Mixed. So properly mixed. After that, this will next pass to the reactor. For example, this is the horizontal reactor. So from here, so any reaction required some particular temperature, maybe high temperature or low temperature, but temperature is required. Why it is required? If you convert any chemical, to convert any two materials into one particular product, you require some particular temperature and pressure. Why? You have studied in intermediate. Why? What are they? Activation energy, na? Do you know activation energy?
Yes, sir.
So to reach activation energy, we need to supply some energy, heat energy. Okay? So then only these two compounds will mix and form a reaction. Okay, we need temperature. So this temperature will describe the heat transfer subject. So you already studied means what is the mode of heat conduction, how the heat will transfer in the solids, in the liquids, in the gases. Now what are the means how to design a one heat transferring equipment? Continuously transfer, not batch wise. Continuously heat has to be transferred. Okay, so how to design that? So like double pipe heat exchangers, single pipe heat exchangers, double pipe heat exchangers. What else? Shell and tube heat exchangers. In shell and tube heat exchangers, what are the good one? Boilers, reboilers. I have studied this now. Boilers I have studied. Boilers, double pipe heat exchangers, double pipe. It is there. No, the one pipe is there. Another pipe is there inside. is there. One is the inlet, one is the outlet. Double pipe we studied already. That is the experiment is there also in the lab
So
also.
always we do.
No, that's not the case. Double pipe is one pipe is there, inside another pipe is there. So one fluid is passing one direction, another fluid is passing another direction. We have studied already. Shell and tube heat exchanger. Okay, shell and tube heat exchanger. So that means how to design heat transfer will explain you how to transfer energy to particular reaction and how to design that equipment. Okay, reaction is taking place here. Okay, reaction is taking place. So chemical reaction engineering, chemical reaction engineering will tell what is the reactor size, how to increase the rate of reaction, how much should be the pressure, temperature. This will be described by the chemical reaction engineering in next semester you are going to study. So that is the chemical reaction engineering. Okay. After that, the product is formed. That is protein powder is formed. Protein or nutritional powder. You are saying nutritional powder is formed. Powder. Please place other unwanted materials. Not desired products. No products can form in a single form. Other compounds will form, surely. So now they are formed. After that, you need to separate them, na? Because I want only nutrition code. We don't want this.
Yes.
If there are more, the cost is very less. If they are very pure, their cost is very high. Okay, so you need to separate. So how to separate them?
Purification.
So that is called mechanical unit operations. So means mechanical unit operation. That subject will teach you how to separate. Okay? So that is. And also, in this also, one more is there. Like it, mechanical unit operation, what is the simple method? Filtration, sedimentation, what else? Sieving, crushing. So for example, my powder is in a very bulk form. I can use the sieving method, mechanical unit operation, to convert it to the very small particles. So means the subject will teach you. Here the subject will be useful. After that, product is separated. And for example, some other only single compound is formed, but water is there along with that. But another liquid phase, another is there. You want to separate. So this is called, next one is the mass transfer operations. Mass transfer operation, MTO. So that is next subject will teach you how to separate two compounds which have a same boiling points. Which have a same boiling point and different boiling points. How to separate them? So after that, the product is separated. So you have to control every step. Because for example, somewhere here it is overflowed. A and B are continuously sending. We don't know, without unknowingly the fluid will overflow. Some other doesn't easily lost also. So how to control? There is a process control system. Process control system will tell how to control the process. So it means whatever the subject you are studied are going to study useful in your industry, the drug industry. How to first one, the fluid mechanics will explain how the fluid, one particular fluid will transfer one place to another place. What are the pressure, what are the equipment are needed, how to transfer them. Pumps, rotatory pumps, different pumps you study. Pumps are studied?
Yes, sir.
So what are the pumps? Name them. One. Centrifugal pump. What else? Name. Centrifugal pump one. Reciprocating pump. You have studied reciprocating pump? Reciprocating. What else? Rotary. Rotary pump. How to create the so this means how to transfer one fluid one place to another place. What is the what is the how to design? So in engineering, you are going to design a industry process. That is your pharmaceutical engineering. Pharmaceutical engineering means you are going to design one drug industry with all the equipments, whatever the equipment. You need to design the process along with the equipments also. What should be the size? For example, you want to cook the 2 members rice in your home. So you cannot take the very big jar. So you will take appropriate one. How to decide that one? This is the industry. How to decide that one? Okay. So that will mean you are going to design the process, drug manufacturing process or pharmacy related process, along with the equipments. How much should be the size? Economically feasible size. Low cost size. What is the material we need to choose? And next, there's a fluid mechanics, how to transfer the heat to reaction, how to control the reaction, and how to separate after the product is formed, how to separate them. After that, how to control them. These are all the subjects. Please write fluid mechanics. First one is the fluid mechanics. You are already studied. Heat transfer, fluid mechanics, heat transfer, fluid mechanics, heat transfer, chemical reaction engineering, mechanical unit operations, mass transfer. Next one, last one is the process control. Process control. So okay, but where are you going to see the thermodynamics here? Where is the thermodynamics?
Sir, with the compound, some amount of heat is given out also, sir, after the chemical reaction. So that is put into work, sir.
Okay, any process, for example, very good. For example, if I want to mix here both them properly, how much accelerator has to rotate? What is the speed? How much work has to be done? How much rate? What is the speed rate? That will be decided. To do this mixing work, how much amount of heat energy or work energy required? Otherwise, next one, reaction. How much heat energy required to convert the A plus B into C plus D? After that, separation. How much work energy is required? Work energy or heat energy required to do particular work. Okay. So not only that, for example, because we don't have a PPT today. So for example, what else thermodynamics will explain? For example, Bharadwaj has given chart now. When he has thrown, what happened? It has broken. Why it is happened? Why? Why always when somebody throw chalk, it will break? It will break. Sorry. Why? Why cannot after the chalk is broken? Why they can all the pieces come together, come in again chalk? Why cannot they happen this process? Only one possible means, for example, one chalk.
Irreversible process.
Why irreversible process are happening like
It
this?
needs certain energy for again formation.
Yes, means for example in this case chalk piece is a very big one. When somebody has thrown, when it is fall on the floor or somewhere, it will break into the pieces. That is the process. Why these processes are come together and become a one chalk again? Why it is not this process not happening? I will provide that much energy. How much you want? How much you want?
Then it will
Huh?
Chalk powder can be again formed into chalk muscle.
Pardon, please. Huh?
Chalk powder can again be formed into chalk anyways muscle. So if you provide the energy, then it will obviously become a chalk again.
But that's not possible. That is impossible.
It's always chalk. Chalk is made in that way only.
For example, what I am saying, this powder is there, has to come together itself, because when I throw it, it is itself is breaking down into pieces. Now, after that, whatever the energy if I provide, will they come together the pieces and become a chalk again? So means the thermodynamics explain why one process in a particular direction only. Why not in other direction? For example, ice cream is there. When I have taken from the store, I have taken ice cream, I kept here with the room temperature. It always melts. Why this ice cream drag temperature from the surrounding can become more ice? Why it cannot happen? Why? So this means no one has an answer for this. But thermodynamics explain this. Why this is happening? Why this is not happening? Why only particular direction only one process is happening? Why in a reverse manner it is not happening? Huh? This is explained by the thermodynamics. So previously everyone said we don't know why, we don't know what is the reason behind this. Why it is not happening? We don't know. But thermodynamics explains clearly because of this reason reverse process is not happening. For example, you take the tree. In the autumn season, the leaves are falling down. Why the leaves are after falling down coming together back and stick to the leaves branches again?
Gravity.
So this is a
Gravity. They are falling.
of course here is the gravity is there because of falling down. That is true. Of course they explain. But the process, for example, ice cream process, what is the driving force is not coming back again. So this is explained by thermodynamics. You will see that. Okay. So means thermodynamics will explain why the one process in particular direction only. For example, another example. Yes, Shivani, I am in the class. After the class, you can meet me. What is the time? 11:04. Thank you. Yeah, I will start with. So, you class is here. Whoever are there. So, you can please remind me at the correct time. There is no wrong in that. Okay?
It is experience.